Good evening to one and all. Myself Nithya. I am currently pursuing my engineering in Sri Venkateshwara College of Engineering, Bangalore, in the Department of Computer Science and Engineering. Today I am here to discuss about the asymptotic notations in the course Design and Analysis of Algorithms. Now let us see the contents. Here we are discussing about the introduction, big O notation, omega notation, theta notation, examples, conclusion. Now let us see the introduction. Welcome to our presentation on asymptotic notations. In computer science, we often encounter algorithms that are designed to perform a specific task. However, not all algorithms are created equal and some may take longer to execute the others. This is where asymptotic notations comes in. They allow us to describe the performance of an algorithm based on its input size. By understanding these notations, we can choose the most efficient algorithms for a given task and optimize our code accordingly. Now let us see the big O notations. Notations are very important to describe the best case, worst case and average case. First, let us see the best case. This is worst case, big O notation, which helps to represent a worst case. Let us see the description. Big O notation is a mathematical notation used to describe the upper bound of an algorithm's time complexity. Here, we represent this as the big O notation. This is the upper bound. This is the upper bound. It is used to analyze how an algorithm's runtime grows as the input size increases. Okay. In other words, it describes the worst case scenario for an algorithm performance. It helps to describe the worst case scenario. It is very important. It helps to describe the worst case scenario for an algorithm's performance. For example, consider a simple linear search algorithm that searches for a value in an unsorted array. The worst case scenario for this algorithm would be if the value is not present in the array and the algorithm has to traverse the entire array to determine this. In this case, the algorithm's runtime would be proportional to the size of the array, which we denote using big O notations as O of n, where n is the size of the array, O is the big O notation. Let us take one examples like 1 to 10. If we have to search the 10 numbers, we have to search one by one from 1 to 1, 2, 3, 4, 5, 6, 7 up to 10. We have to search from 1 to 10. So 10 will be at the last. So the searching time would be, it takes very longer time and it takes many steps. So our output will identified at the last. So this situation we called as the worst case, and this situation we can represent by the big O notation. Now let us see the omega notation. Omega notation is another type of asymptotic notation used in computer science to describe the lower bound of an algorithm's time complexity, which big O notation describes the upper bound, omega notation describes the lower bound as a best case scenario for an algorithm's performance. For example, let's say we have an algorithm that has a best case time complexity of O of n and a worst case time complexity of O of n square. We can use omega notation to describe the best case scenario, which would be omega of n, as well as the worst case scenario, which would be O of n square. This helps us get a more complete picture of an algorithm's performance. Let us take same example from 1 to 10. We have to search first number. One number. One will be at the first place. So if we get the output at the first place, we need not to search our output from 1 to 10. we get the output at the starting. So this we called as the best case complexity. I mean, okay, but this is called as best case complexity, and this is represented by the omega notation. Omega notation is used to represent a best case complexity. Now let us see the theta notation. Theta notation is used to describe the average case time complexity of an algorithm. It represents a tight bound of the running time of an algorithm and is used when both the upper and lower bounds are the same. In other words, if an algorithm has a worst case time of O of n and a best case running time of omega of n, then its average case running time can be described as theta of n. Theta notation provides a more precise description of an algorithm's performance than either big O or omega notation alone. Here, this is upper bound and this is lower bound, this is middle bound, and this is the coincide I mean coincidence point. Theta notation. It mainly used for representing a average case time complexity. Here, let us say take same example from 1 to 10 numbers. We have to search the fifth number. No, 5. We have to search the 5. From 1 to 10, we have arranged the numbers in the ascending order. Here, 5 will not present in the starting, 5 will not present in the ending. 5 is present at the middle. So, this case is known as average time complexity. It will not take less time, it will not take more time. It will take average time. So, it is known as the average time complexity. Finally, let's see the conclusion. In conclusion, asymptotic notations plays a crucial role in computer science by providing a standardization way to describe the performance of algorithms. Big O notation describes the upper bound of an algorithm's time complexity, as we have seen in the previous slides. Then omega notation. Omega notation describes the lower bound and theta notation describes the average case. By using these notations, we can compare different algorithms and choose the most efficient one for a given problem. By using these three notation, we can identify the complexities like worst, best, and average case complexities. It is important to note that while asymptotic notations are useful, they do not provide an exact measurement of an algorithm's performance. Other factors such as hardware and input size can also impact the actual runtime. Therefore, it is important to use asymptotic notations as a total for analyze and comparison rather than as an absolute measure of a performance. By this conclusion, we can know that firstly, we described about O notation, theta notation, and finally, we had discussed about the omega notation. These three notations are used to describe best complexity, worst complexity, and average case complexities, and we can represent them as by the symbols. Hope everyone understood this concept by listening complete this complete video. Thanks for watching video and thank you so much.